27. 27 asks the question, what's the equation of the line through the point 5, -1, and -1, 2? Well, the first thing we need to do is we need to find the slope. So we use our old friend, the slope formula. And we get 3 over -6, which is -1/2. And then we pick out our favorite point, and let's use this one. Y equals m times x plus b. And this would give me b equals 1 1/2. So the equation would be y equals -1/2 x plus 1 1/2. Okay. All right. Number 28. Is a problem that asks the burning question, if -2, 3 and 1, 1 are points on a line, explain what you would do first to find the equation of the line, then write the specific equation for this line. Well, the first thing I would do is I would find the slope, because to write the equation of a line you need the slope and at least 1 point. Well, we've got 2 points, but we don't have the slope. So again, I would get out my old friend, the slope formula. And I got 2 over -3. Yes. Sure. So then I would pick out a point that I like, and let's use 1, 1. And y equals mx plus b. So b equals 1 2/3. So y equals -2/3 x plus 1 2/3. Number 29. All right, number 29 says that Jerry was jogging with her friend Josie and talking about how fast she could jog. Jerry said she takes 2 minutes to get around a 100-meter track, and she could run that speed all day. Josie wants to run in the 5K, but only if she can keep up with Jerry. Josie can run a 5K in 1 1/2 hours. Will Josie be able to keep up with Jerry? Well, what we need to do is calculate their rates. And Jerry can do 100 meters in 2 minutes. And it's kind of like, wow, that's not impressive at all. But that's 50 meters per minute. So it takes you about a minute to walk half the length of a football field. Yeah.
So half of that is a minute?
Yeah. Half that's a minute. We're getting a football field in about 2 minutes.
Wow.
Okay. About a football field. Just a straight part on the track. 2 minutes for that. Okay? Hopefully Jerry and Josie are a part of the geriatric set. Alright. And Josie could do 5,000 meters in 90 minutes. Alright, so if we calculate that one out.
Wait, 5K, 90 minutes?
Yeah, 5K, 90 minutes. So she's going at 55.6, and that's meters per minute. Okay, at that rate, Josie doesn't have to worry about keeping up with Jerry. But somehow I think I could walk 5K in 90 minutes.
Yeah,
You know?
average was like a mile and 12 minutes.
Yeah, that's,
So it's about 3 miles. Yeah, I could do almost to 6
yeah. So, you know, I'm thinking that, and let's face it, I'm not exactly the epitome of health. So, number 30. We have Tong has $350 in his savings account and has a part-time job where he's able to add $30 per week to his account. So he's got $350 and he's adding $30 per week. Wing, his sister has $620 in her savings account, but is only saving an additional $18 per week. So her amount is $620 plus 18x. When will Tong have more in his savings account than Wing? And if they both continue to save at these rates, answer the question using equations and clearly showing all work. Well, if you set these things equal to each other, 350 plus 30x equals 620 plus 18x, and I get all the x's on one side and all the things that aren't x's on the other, I get 12x equals, I'm thinking that's going to be about, what, 270? And then if I divide each side by 12, I believe that I get x equals 22.5 weeks. So we should really say 23 weeks. Okay. 31. Sadie has an exceptionally mean math teacher. Well, that could be me. It's been a few years since I've had a student named Sadie, but I have had one. Well, Sadie needs to get over here because I'm the mean one between the two of us. Or at least that's what Sadie thinks. The teacher gave Sadie 100 lines to graph by the next class. Sadie begins whining about it to her friend Matisha. 100 lines? Can you believe it? And then he goes, and they're all equivalent. Sadie continues, I have enough to keep busy graphing all 100 lines. I'm not going to worry about that.
Well, if they're all equivalent.
She finishes with a harumph. Matisha responds, well, maybe you should pay attention to that. I think your teacher helped you out greatly with that one little statement. What is Matisha talking about? Should Sadie be whining over this assignment? If Sadie can graph the first equation correctly on her list of 100, what is the probability that she will graph all of them correctly?
She'll probably mess up because she'll be like thinking about it.
Explain all answers completely. Well, if they are equivalent equations, their graphs would all be the same line. So as soon as she graphed one, she would have graphed all 100. Oh, yeah. All right.
That's more like an
Number 32. One evening, One evening, 1,255 people went to the theater to see Gone with the Wind. The box office receipts totaled $12,295. $12,295. All right, the price of admission for adults is $10, and for children it is $7. How many of each type of ticket did they sell, adults and children, and show how you would solve this problem using a system of equations? Well, I would say that A plus C equals 1,255, unless we have developed a new classification for people as adult or children or something else. Now, that would tell me that, let's see, $10 times every adult. Well, it's thinking about it this time. Okay, you got to send the signal a foot and a half. Take care of it, computer. It's being slow. It's being very slow.
How sensitive is that microphone?
Very.
Oh, okay.
Well, ever 10 adults plus 7 children would equal $12,295. And if the computer, if my iPad ever catches up, oh, we took a jump, more. It thinks it can, it stopped. Oh, wait, there, oh, here we go.
It's a miracle.
10 adults plus 7 times the number of children equals 12,295. And now it's going to be dumb.
That's the one I have, right?
Yes, it should say 10A. $12,295. All right, so what I would do then, is this going to work? No, of course it's not. I'd multiply that top equation by 10, subtract the bottom one from the top one, and that would tell me that there were 85 children and 1,170 adults. Okay. And we'll let this catch up. All right.